This video is on heating and cooling curves. So this is heating of a solid. So obviously once a solid is heated, it eventually will get to a point where it will melt, turn to liquid. Eventually that liquid will get to a point where it will vaporize and turn into a gas. So most people probably think that a heating curve, if you just heat a solid up, they probably think the curve would just go up in a straight line. But there's actually going to be segments where the temperature goes up and some plateaus in temperature. So this graph is just showing time here. So time going across, and this is showing the temperature as we add heat to the substance. So a couple of types of energy we need to be worried about here. Thermal energy, which is just heat energy. Okay, so in this case, thermal energy is being added the whole time. Even when the graph is flat, we're always adding thermal energy. So they put this solid, whatever it is, on something warm and it is staying there. So they're never taking it off of the heat. So thermal energy is being added continuously this whole time. The thermal energy is either changed into potential energy, which is just stored energy, like we store energy as fat in our bodies, or kinetic energy, which is energy of motion. Now, if we think of temperature as the motion of the molecules, when temperature goes up, kinetic energy increases. So temperature is a measure of the kinetic energy of the molecule. So as the temperature is increasing, that means the kinetic energy of those molecules is increasing. Molecules are starting to speed up and move faster. If temperature is going down, the molecules are slowing down, getting closer together. So in this graph here, first of all, let's label solid, liquid, gas. So at the coldest temperature, obviously, this would be when the substance is a solid. Right here, the substance is a liquid, and up here, it is a gas. So that means here, the substance is a solid. It's just being warmed. Thermal energy is being added. This would be an increase in kinetic energy. Molecules are moving faster and faster and faster. So right here we have an increase in kinetic energy from there to there. Here the substance is changing state. So if I ask you what is the melting point of the substance, you'd say it's about 50 degrees Celsius is the melting temperature or melting point. That's also the freezing point. So to make a liquid turn into a solid in this case would be 50 degrees and below. We'll do that. 50 degrees and above, it will go from a solid to a liquid. So this would be melting. Notice what happens to the substance as it melts. And this is true for every substance. As a substance is melting or freezing, the temperature remains constant. Most people think that it increases. So the warmest a piece of ice can be, it's solid, is 0 degrees Celsius. As it's melting, it stays at 0 degrees Celsius. The liquid then can be warmer than that. So very important to know that as things are changing state, temperature does not change. So in this case, the thermal energy, we're still adding heat to make the substance melt, still adding thermal energy. In this case, the thermal energy is being stored as potential energy. Eventually, when the substance gets enough potential energy, it's now a liquid. Now the temperature can start going up again. You'd have an increase in kinetic energy here as the temperature is increasing. Molecules move faster. Eventually, they get enough energy to start to vaporize, so this would be vaporization. So this would be the boiling point of the substance would be 110 degrees Celsius. It would also be the condensation temperature if we're going the opposite direction. So as a substance boils, so as water boils, it stays at a constant temperature. And it can't get any warmer than that at room pressure. Then here, obviously, the substance is a gas. From there. So energy changes again. We're adding thermal energy the whole time. Here's an increase in kinetic energy, increase in potential. Here's an increase in kinetic. This would be thermal energy is being converted to potential energy. Right here, the potential and thermal energy is being turned into kinetic energy. Okay, so you have an increase in kinetic energy from that point on. That is obviously the heating of a solid. We could do the opposite as well. You could have cooling of a gas. So I won't go through this whole thing. One important thing, sorry, it's a little bit crooked, but would be that this. So we're starting with a gas. To make a gas turn into a liquid, so that would be condensation right here, gas to liquid, and right here would be freezing. So I'd say, what is the freezing point? 50 degrees Celsius in this case. One thing that's important is this graph would be exothermic. It's showing the gas is giving off heat to the surroundings, meaning the gas is cooling. The graph before, when we were heating a solid, would be an endothermic. You're putting heat into the solid. Okay, so this would be an exothermic one. The other one was endothermic.